Welcome to today's webinar, an overview of designing microservices based on applications on AWS. Our presenter today is Peter Dalabunjan. Peter is a solutions architect for AWS based in Herndon, VA. Peter has a keen interest in DevOps and microservices and strongly believes that one cannot coexist without each other. At AWS, Peter helps with designing and architecting a variety of customer workloads. Today we also have Prahlad Rao, Brandon Chavez, and Hui Wen. They'll be our moderators today, answering your questions that you submit through our Q&A panel. Peter, welcome. The floor is now yours.
All right. Thanks, Jerry. Welcome to today's webinar. So my name is Peter Dalabunjan, and I'm a solutions architect for Amazon Web Services. And like Jerry said, we will be doing an overview of designing microservices-based applications on AWS. Before we move along, just so everyone knows that this presentation is being recorded, and both the webinar and slides will be made available to you in a couple of weeks. If you have any questions, please post those in a chat window, and we have our moderators who will help answer those questions. If we are unable to get to your questions, I would recommend to reach out to our forum posts, review our documentation, or reach out to your account teams to facilitate those conversations. Just a quick reminder here, because this webinar is open to the public, we will not be able to disclose roadmap items. You can reach out to your account teams, and they can certainly facilitate those discussions under NDA. Let's get started. So here's the agenda for today. We will take a look at the evolution from monolith to microservices. And then we will review several approaches that you can take in order to build a microservices application on AWS. And we'll take a look at some of the core principles, some best practices that we recommend in order to, when you design your microservices application. And lastly, we'll do the demo. Just another reminder here, this is a 200 level session, which means you need to have some level of knowledge and experience about the AWS platform. Although what I'll do is I will cover high-level aspects of some of the AWS services that I'll cover to keep it informative to new users. So you've probably seen the slide. This comprises the entire AWS platform and the number of services and workload it enables. So you can see that we have services for data analytics, IoT, mobile applications, artificial intelligence, enterprise applications, game development, and so on. And here's a slide on our pace of innovation. So last year we did announce around 1,017 new features and services. And in February, that's this year, we announced around 69 new features and or services. And this represents about 25.5 increase over 2016. And we continue to innovate on behalf of our customers. 90–95% of our roadmap is based on what customers ask for. And one of the reasons why customers choose the AWS platform is because of the speed of innovation, as we build more and more features that customers want. But it wasn't always this way. Amazon used to be built using a monolithic architecture. I don't know about you, but around year 2001, we found our biggest bottleneck at Amazon. At the time, it became increasingly difficult for our software developers to integrate new features into Amazon.com webpage. Also, understand the data that came in through our e-commerce operations and react quickly to customer feedback. The reason was that Amazon.com website had turned into this large, complex and difficult to maintain thing, which is called a monolith. used to be built using OBIDOS as a code base and largely C++. So over time, the set of features on Amazon website grew, and the OBIDOS code base began to sprawl. The binary was multiple gigabytes and took a very long time to compile. So in the early mid-2000s, the company began to switch to Gurupa. Now, Gurupa is a web server that could only talk to databases and file systems through BSF, an in-house equivalent of Thrift. And then when the services gave the data to the server, it would assemble them into a web page using Meson templates, which is basically Perl interspersed with HTML files. It feels a lot similar to PHP. Over the period of 2.5 years, I think around 2004, 2005, the company migrated to OBIDOS, from OBIDOS to Gurupa completely. So we observed there were several challenges with monolithic software. First, it was very difficult to scale, and it had long release cycles. People were always afraid to make a new release because they were not sure if their new feature will impact other features, and operations was a nightmare. Because the code was so complex to maintain, there was lack of innovation and lack of developer freedom to build software and add new features they wanted. And due to the lack of agility and innovation, what you end up with is frustrated customers. So at Amazon, one of our leadership principles is to dive deep, a practice of doing the 5 whys, asking why to get to the root cause of the problem. And we identified a few root causes. What we understand was the root cause were 2 key ones. So when you're working with a monolithic app, you have many developers all pushing changes through a shared release pipeline. And this causes frictions at many points of the life cycle. During development, engineers need to coordinate their changes to make sure that they're not making changes that will break someone else's code. If you wanted to upgrade a shared library to take advantage of a new feature, you needed to convince everyone else to upgrade at the same time. And if you want to quickly push an important fix to your feature, you still needed to merge it in with everyone else's process changes. And this led to merge Fridays, or worse yet, merge weeks, where all the developers have to compile their changes and resolve any conflicts for the next release. Even after development, you're faced with an overhead when you're pushing the changes through the delivery pipeline. You need to rebuild the entire app, run all the test suites to make sure that there are no regressions, and redeploy the entire app. Just to give you an idea of this overhead, Amazon had a central team whose sole job was to deploy this monolithic app into production. Even if you're just making a one-line change in a tiny piece of code you own, you still needed to go through this heavyweight process and wait to catch the next train leaving the station. Now, for a fast growth company trying to innovate and compete, this overhead and sluggishness was unacceptable. So we made a couple of big changes. One was architectural, and the other was organizational. What we found out was we needed to go towards shared nothing architecture, an idea that is now known as microservices. So what defines a microservice? You can certainly look that up in Wikipedia, and you'll find a pretty good definition up there. But the one that I like the most and that captures the essence of what a microservice is, the definition by Adrian Cockcroft, one of the luminaries of cloud computing. What he says is the software is defined by a service-oriented architecture, which means they all communicate over network, and they are loosely coupled elements. which means you work on your code, have independent release cycles, and you innovate on your own pace. You're not afraid that your new feature will cause an impact to other microservice applications. And the software design methodology is largely self-contained. They go with the primitive share nothing in terms of libraries or database, so they can coexist and have independent release cycles. Another paraphrase that you'll hear along with microservices is do one thing and do it well. If you take the analogy of a Swiss Army knife, you can see that each component is specifically designed to do one job. Here is another image to demonstrate a set of tools that are designed to do one thing and do it well. So around this time, we implemented a company-wide mandate to move towards microservices. Now let's take a look at the anatomy of a microservice. The first thing you'll need is a data store. It could be a relational data store or a NoSQL data store. And then you'll need the application logic that goes with your microservice. Now what you do is you would then expose this over a set of APIs, a RESTful API. So this design would allow you to avoid software coupling, because now you are no longer having shared libraries or a shared data source, and evolve into an ecosystem of microservice. So let's say here I'm highlighting an application. For example, if you want to build an application such as restaurants near you, this is how the high-level software design would look like. You would have a restaurant as a microservice, another microservice for location, another for payments, ordering, and so on. And they would all communicate with each other using a RESTful-based API or a queuing system. And this is exactly what you see on Amazon.com page. Each component that you see here is a microservice, like product catalog, shopping cart, reviews, frequently brought together experience, other sellers, and many more. This whole experience is carefully designed to make it simpler, but still offer a great amount of detail when you make a purchase out of Amazon. So what does success look like? Now there are a lot of ways you can measure the process, and no one way is perfect. But here is one data point. When you have thousands of independent teams producing highly factored microservice, and that are deployed across multiple dev, test, and production environments in a continuous delivery process, you get a lot of deployments. At Amazon in 2014, we ran over 50 million deployments. And that's an average of 1.5 deployments every second. So other companies are going through the same journey, like what Amazon did. And here is a talk that I'm highlighting that was given by Gilt, an online retailer. So they talked about their journey to microservices during reInvent of 2016. reInvent is a technology conference that we do usually at the end of the year. And what they talk about is each of their service has its own binary, its own data store, and a load balancer. And they mention how efficient it was to scale their microservice using this approach. They also highlight a strangler pattern that was described by Martin Fowler. So you would use this method in order to decompose a monolithic architecture into a microservice architecture. So I recommend you to take a look at the video that is up on our YouTube channel. Now here is another customer that gave a talk about their microservice journey, which is Nike. And they talk about how immutable deployment, share nothing, and continuous delivery help them with time to deploy a new feature from weeks to sometime months to hours due to microservices. They also talk about achieving deployment quality to zero downtime. And also they were able to reduce 150,000 lines of code per project to 700 to 2,000 lines of code in a project, which is pretty amazing. Similarly, you'll see Netflix, Expedia, Capital One. They've all talked about their microservices journey during our reInvent conference. So I recommend you to check out some of these videos on our YouTube channel. Now let's take a look at how to design these microservices and what approaches you can take on AWS. So approach number one is you can simply start with EC2. So you can have your application binaries loaded on EC2 and have a data store where you can store all your data. Use scalar EC2 by putting it in an auto-scaling group, attach it to a load balancer, and this is a pretty good design. And this is what Gilt was talking about using by deploying their microservices using this technique. What I recommend is to leverage Elastic Beanstalk in order to deploy and manage this service. Now, Elastic Beanstalk is an easiest way to deploy microservices on EC2. You can simply upload your code, and Elastic Beanstalk handles all the automation that is required, starting from provisioning your instances, adding load balancing, and putting your EC2 in an auto-scaling group. All of that is handled automatically for you by Elastic Beanstalk. Here's a slide that talks about what all the components that are handled by Elastic Beanstalk. So you can focus on your application code and improve your application code and focus on your business and let Elastic Beanstalk manage the AWS infrastructure for you. Elastic Beanstalk supports multiple languages such as Java, .NET, PHP, Node, Python, Ruby, Go, and also Docker. So if you're in a using Docker to deploy your applications, you can use Elastic Beanstalk in order to manage and deploy your applications within a couple of lines of command lines. So here's another approach. Approach number two is if you're leveraging containers in order to deploy microservices, you would use EC2 container service. Now, what is ECS? ECS is a cluster management system, and it is the simplest way to deploy and manage your Docker containers. To understand about ECS, to put simply, there is nothing to run or manage. ECS is offered as a managed service, and it offers reliable scheduling of your containers. It gives you full control and also monitor the state of your containers. Another neat thing about ECS is it's free of charge. There is no cost associated with using the service. You pay only for the number of EC2 instances that you run in your cluster and for resources such as ELB and other components like databases. In addition, ECS handles scaling of your container workloads pretty efficiently. So what type of workloads can you run on ECS? You can run long-running applications like web or application servers. You can run batch jobs. Or if you needed to integrate third-party schedulers such as Mesos or Marathon, you can do that with on top of ECS scheduler. And like most managed services, ECS is designed to work with the ecosystem of services within AWS. So it has direct integration with the Elastic Load Balancing service. That's the software load balancer that we have on AWS. It integrates with Elastic Block Store. That's our persistent storage. Integrates with VPC. That's our networking construct. Identity and access management, CloudTrail, etc. So how would that look like if you leverage containers in order to deploy your microservices? You would run your containers using ECS. That's the only change. Now, approach number 3 is to leverage API Gateway and Lambda in order to deploy your microservices. And this technique is completely serverless. There are no servers to manage. So if you want to deploy your microservices that adhere to serverless methods, like asynchronous applications, you can go down this route. So what is Lambda? Lambda is a service that lets you run your application code without managing servers. So you can simply upload your application code that is written in Java, JavaScript, or Python onto Lambda and set up triggers in order to run that particular application. And that trigger could be an AWS service like CloudWatch Events or S3 event, or it could be a web service that is triggering the application, or it could be even your mobile application. A neat thing about Lambda is it automatically scales, so you can run hundreds or thousands of Lambdas in parallel. And you pay only for the compute time that you use. So what is API Gateway? API Gateway is the easiest way to deploy your microservice. With API Gateway, you can publish APIs at any scale. The neat thing about API Gateway is you can abstract your backend implementation. So you can run your microservice using Lambda or EC2 or ECS, and you can switch across between them. You can combine multiple backends. So API Gateway gives you that flexibility where you can keep your backend implementation abstracted from your APIs. Another neat thing about API Gateway is it offers you network level protection. So network protection is something that we do very well, and it requires hyperscale. You won't be able to auto-scale to meet an attack. So let us do that for you. You can centralize authorization decisions in a policy and remove the concern from the code in your backend. That way you'll have fewer bugs. So those were the 3 different approaches that you can take in order to design your microservice application. Now let's review some of the principles, design principles that you need to adhere to while designing microservices-based applications. So the first principle is microservices rely on each of these public APIs. And you might have gotten a gist of this as I was talking earlier. So let's say if you have a service A and service B that need to talk to each other, and service A needs to access the data that is hosted on DynamoDB, our NoSQL solution, a managed NoSQL solution. So if it is trying to access that data, you would not allow that. So in other words, hide your data. If services need to interact with each other, the only way they access the data that you're hosting is through the public API. Another best practice here while you're designing your APIs is as you evolve your APIs, it is important to keep backward compatibility for older versions and to document and communicate during upgrades. So here, as an example, if we go back with the restaurant-based application, if you have version 1.0.0 with certain properties of storefront, store restaurant API, and you wanted to add additional properties, you would keep the older version and let the other services that are using your APIs know that you're doing this minor upgrade, and give them enough time to go ahead and do the change their properties so that they are, whenever they access the data or your APIs, they change that pattern. And then in your major release, you would take away the older version. In other words, do evolve your APIs in a backward compatible way. So that's principle number one. Principle number two is use the right tool for the job. And what I'm highlighting here is whenever you design your application, you want to embrace polyglot persistence. What I mean by that is if your application is well designed using a NoSQL solution, then embrace a NoSQL solution. If it requires a SQL-based solution, use RDS-based solutions. And you have managed services to take advantage of. So if you have a NoSQL solution, you can leverage DynamoDB. If you needed to add a search component to your API, you can leverage Elasticsearch service. That's another managed service in order to provide search components for your APIs. And if you needed to replace DynamoDB with an RDS solution, let's say your application would behave very well with an RDS highly scalable solution such as Aurora, you would leverage that. So embrace polyglot persistence. The same thing goes with your programming frameworks. So if your application is well written using Java, or if your developers feel comfortable writing application using Java, you would leverage that. Similarly, if your application can take advantage of Node, you would embrace that. So embrace polyglot persistence as well as programming frameworks. The third principle here is secure your services. And here I'm highlighting a microservice that is managed by EC2 container service. But if you run your application using EC2 or Elastic Beanstalk, similar techniques will apply in terms of security. So you would take advantage of VPC security groups and VPC routing and NACLs in order to secure accessing your microservice. You would also use IAM roles in order to secure access to your AWS resources, and IAM policies for user-level authentication and authorization. With the advantage of using ECS is with ECS you can push down the role onto your containers. So imagine you have several containers that are running on EC2, and one container needed access to read-write access to S3 data, and the other container needed read-only access to DynamoDB. You can certainly do that pretty easily with Amazon EC2 Container Service by applying IAM roles for containers. You can also enable CloudTrail. CloudTrail is a service that gives you a history of API calls made to your AWS resource. And this service is heavily used in order to enable governance, auditing, compliance for your AWS account. So certainly take advantage of CloudTrail type services. And if your use case requires secrets management, I'm highlighting a couple of services here, like parameter store or S3. So you can store your secrets or your configuration data in parameter store and or S3, and you can encrypt the secret using KMS and have IAM roles in order to control access to these secrets. And there are also multiple open source tools that I'm highlighting in these slides. So with respect to API Gateway supports similar type of mechanisms in order to provide access control. You can use IAM policies and roles in order to enforce access control to your entire set of APIs or individual methods. There is another service called AWS Cognito. Cognito is a managed service that is pretty popular with serverless authentication and authorization, and is designed to give you customizable authorization solutions for API Gateway. Cognito has a couple of features such as user pools. So you can use user pools in order to add user registration and sign-in features for your mobile or web-based applications. Federated identities is if you needed to enable unique identities for your users and authenticate them with federated identity providers such as Amazon or Facebook or Google, or even SAML-based identity providers such as Active Directory. You can do that with federated identities. Another feature here that you get readily with API Gateway is API throttling. So you can control the rate of requests to your APIs based at the stage level or at the method level. So principle number 4 is to be a good citizen within the ecosystem. What I mean by that is communication is the key as you keep growing your microservices-based applications. So let's say service A owner wants to talk to service B, and service B owner would put a set of questions asking which APIs do you need to call? What's your request response limit? What kind of permissions do you need, etc. So the responsibility goes both ways. Service owners have a responsibility in order to publish their health metrics as well as monitoring metrics so that other services that are using your service are aware of any problems that are going on. And clients have a responsibility to do exponential backoff in case if they hit errors due to rate limiting. And like I mentioned, API Gateway gives you this flexibility, so you can control how many TPS each services that are accessing your microservice can handle. And you can do it at the stage level as well as method level. So one of the other challenges that you'll run into as you keep growing the number of microservices, it becomes really hard to track and log the microservice-based applications. But it is very important to spend time working on the code that analyzes the meaning of metrics than code that collects, moves, or stores and displays metrics. And also reduce the key business metric latency to less than the human attention span, which is usually less than 10 seconds. And I highlight a couple of metrics here. In terms of shared metrics, you want to be able to show the service dependencies, the number of services that you use for your microservice, so that other services that are using your microservice are aware of the service dependencies, and also the request and response time. And it's important to measure user experience metrics as well, such as status codes, latency, error counts, time to first byte, etc. Another important thing to note here is monitoring systems need to be more available and scalable than the systems or services being monitored. So optimize for monitoring distributed and cloud-native containerized microservices. One of the services that we pre-announced during reInvent of last year was AWS X-Ray. Now AWS X-Ray, this is still in private beta, But you can gain access to this just by simply signing up, by going to AWS X-Ray service page and putting in a request saying, I need access to the preview, and you'll get access within a day or two. I recommend taking a look at the service, kick the tires and see how the service works. I do have a demo in a couple of slides. I'll show you at a high level how things work and look and feel about AWS X-Ray. So AWS X-Ray is, at a high level, it's a distributed tracing service that enables developers to analyze the behavior of your applications. It provides end-to-end view of requests as you travel through your application. And it shows a map of your application's underlying components. The service map lets you see relationship between all the resources in your application in real time. You can quickly see where high latencies are occurring in your application and then drill down into specific service and paths that are performing poorly. So you might ask, how does X-Ray does this? X-Ray captures trace data from code running on EC2 instances, also ECS containers, Elastic Beanstalk. Within Elastic Beanstalk, it's available as a checkbox. You can also capture trace data from API Gateway, Lambda, and many more. It implements follow the thread tracing by adding an HTTP header to requests that do not already have one, and passing the header along to the additional tiers of request handlers. The data that is collected at each point is called a segment and is stored as a chunk of JSON data. A segment represents a unit of work and includes request and response timing, along with optional subsegments that represent smaller work units. And it can go down as deep as the line of code if you supply the proper instrumentation. A statistically meaningful sample of segments are routed to X-Ray service, which is a daemon service on EC2 instance and also inside a container. And these segments are then assembled into traces, which is a group of segments that share a common ID. And the traces or segments are further processed to create service graphs that visually depict the relationship of services to each other. So before we take a look at principle number 5, let's go and take a look at the demo. So here is a microservice that I'm monitoring using AWS X-Ray. And I'm running this microservice on Elastic Beanstalk. Like I mentioned, if you run your microservice on Elastic Beanstalk, you can go and enable X-Ray as a checkbox in order to get this data. So I have a 3-tier microservice, a front end, a back end, and DynamoDB. That's my database. I'm also using SNS to send out email notifications. So if you want to take a look at what the service application is, this is the application that is running. I want to let everybody, all the users, know that my next big feature is coming. And if they want to sign up, if they're interested to try the beta, they can put in their name, their email address, and select if they're interested in preview access, and click sign up. By doing that, the SNS will send them an email saying a confirmation that you'll get an email or a link in order to try the private beta. And also, I'll be able to capture the data that they put in there in DynamoDB table. So I have a load runner application using Locust that I'm sending this a bunch of requests to my microservice-based application. That's why you can see I'm collecting a lot of data here. So let's go take a look at some of the traces that you can capture using X-Ray. As you can see, my URL or my application is doing fairly okay. You know, I'm able to get about 1.5 milliseconds of request response for 86% of the traces. But my remote sign-up page, that's where they can go and sign up for requests, that is taking significantly long. So we'll go and take a look and see why that is happening. The other problem is I'm hitting a lot of errors. So you can see that 102 errors at this URL, which tells me that I have to go and take a look at that URL and fix that. And also you can see here my 200s and 201s saying that the record is written, and I'm getting some 404s. We'll take a look at that. So let's go and take a look at my 201s and see where the significant amount of time is taking. So here you can see out of 475 milliseconds, about 460 milliseconds is being used by SNS. So that tells me that there is some issue with SNS that is going on. So that's one tuning parameter that I can use in order to take a look and troubleshoot. You can go ahead and take a look at the status codes. Here's another view that you can analyze the data. And here you can see 201s, some of the requests or the average latency for 201s saying that the record is written is sometimes it's taking significantly amount of time, about 3.4 seconds. So if you go ahead and click the trace data, you can see that it's spending a lot of time in writing a record to DynamoDB. So that's a great level of detail that tells me that I have to go and tune my DynamoDB database and increase the throughput to get proper efficiency for my DynamoDB data. The other thing is, so I mentioned earlier that I'm getting a bunch of 404s for a link. So you can go and take a look and see that there's 100% of traces are getting errors, about 244 errors. So that tells me I have to go and fix this this link. Oh, there's a bunch of 500s and 409s. Let's take a look at 500s and see what that is. So you can click at the status code and click on any of these traces, and you'll see that it's the DynamoDB is having some throughput exceptions. So you can click on the trace data, and you can see that the feedback that I've gotten from DynamoDB is the level of provision throughput for the table has exceeded, and I need to go ahead and increase the provisioning level, which is pretty detailed. I know readily that my provision throughput is an issue, and that's why I'm getting the 500 or internal server error. So that I can go ahead and fix that issue. The other one is 409s, which is if I'm so within a piece of code, I've highlighting that if few customers use the same name or same email ID, give me the response saying there's conflicting. So it's good to see that I can go as deep as I can within my code as well and capture that using AWS X-Ray. So that was just a quick demo to show how what kind of data that you can capture and do the analysis and take care of the issue. Now let's go back to our presentation. So principle number 5 is it's more than just a technology transformation. Now here's a quote that I pulled from Melvin Conway. Apparently he highlighted this in 1967, and it's about communication between teams. So it's not only about changing the software architecture, but also changing the way software teams are organized. And Martin Fowler talks quite a lot about this as well. So if you have teams that are organized based on their expertise, like if you have a group of UI specialists, middleware specialists, database admins, you'll see that they tend to work on their particular application, and this leads to siloed application architectures. And if you go and have groups with a mixture of expertise, then you see there is more collaboration and effort involved in order to create self-contained services. And this is exactly what we did at Amazon. In conjunction with breaking apart the architecture, we also broke apart the organization. We split up the hierarchical organization into smaller teams. And we called them 2 pizza teams. Because if they got larger than you could feed with 2 pizzas, we'd break them up. Another important change that went along with this is cultural. When we split up the org, we gave the teams full autonomy. And they became small startups that owned every aspect of their service delivery. They worked directly with their customers, whether it's internal or external, set their roadmap for their application. They designed their features, wrote the code, ran the tests, deployed to production, and also supported operational aspects of your microservice. If there was a pain anywhere in the process, they felt it. The operational issue, if there was an operational issue in the middle of the night, then the team got paged. If the customer created support cases, the team would go and solve these tickets. And that motivation ensured the team focused on all aspects of the software release cycle, broke down any barriers between the phases, and made the process flow as efficient as possible. Now, we didn't have a term at the time, but this was the start of our DevOps culture. And principle number 6, which is the last principle, is automate everything. And with these new tools, we completed the puzzle. The teams were decoupled, and they had the tools necessary to efficiently release on their own. So you can see each pizza teams created their own release cycle, had their own independent pipeline, and deployed their microservice, had their own pace of innovation. And this is why you can see that the rapid release cycle that comes out of AWS is because of this. And there's tons of managed services in order to help you in this journey. I spoke about a few of these during the presentation. So RDS is a relational database service. It's a managed service that supports multiple engines like MySQL, Postgres, RDS Aurora. DynamoDB is our NoSQL solution. Elastic Cache, so if you have a caching-based microservice that takes advantage of Memcached or Redis, you can run that over Elastic Cache. So there's tons of service. I think these are the services that are quite heavily used while designing and managing your microservice application. And expect to have challenges along the way. It's important to understand your business domain. Operating a monolithic might be simpler and easier, but when you can't innovate quickly, migrating to microservices gives tons of benefits, both organizationally and architecturally. But there are definitely challenges, and I've highlighted some of those challenges during this talk earlier. Complexities such as test release cycle. There are lots of moving parts, so you need to have a very well-designed monitoring and distributed tracing service, and you can certainly take advantage of AWS X-Ray in order to make this journey a little bit more simpler. So here's the recap of principles that we discussed, the 6 principles. And like we mentioned earlier in the webinar, these presentation slides as well as the webinar will be available on the YouTube channel, so you can check it out later. And here are the benefits of microservice. So you can easily scale based on your individual microservice. You can have rapid release cycle. You can have clear ownership and accountability. And this leads to increased agility and faster innovation and delightful customer experience. And there's no shortage of resources. We have our DevOps page, so I recommend you to go and take a look at our DevOps best practices. We also wrote a white paper that came out in December of 2016, so I recommend you to take a look at the white paper. A lot of best practices that I've highlighted today is in that white paper. You also have tons of reference architecture and blog posts. I've highlighted some of them here, so certainly take advantage of them later after the webinar. So that's all I had for today. Let's go and take a look and see some of the questions.
And thank you, Peter. Thanks for the great presentation. On your screen now, you'll see 3 live poll questions at the bottom of the screen. You'll have 1 at the top of the screen also. Your feedback is very important to us, so please take time to complete those. You can still add questions in our Q&A panel in the upper left part of the screen now, and we'll be running our Q&A here for another 4 minutes or so. Now, while you continue submitting those questions, we're going to address as many as possible in that time, but we do apologize in advance if we are not able to get to them all. So let's start our Q&A portion.
So I'm just taking a look at some of the questions. So there's a question by Aaron, and he asks, if you protect your microservice with JWT tokens from Cognito, do you pass the JWT from service to service if you require service to speak with one another? So JWT tokens is one method in order to secure your Cognito application, but there are several other techniques. I talked about the user pools where you can create your application, your users. Within the application, you can also have federated identities coming from other federated identity providers. That is another method. But if you are using the JWT tokens, then you would use that within your application and not pass that along from service to service. There's another question by Surendra. He asks, what about inter-service communications? Will it not become a chaos? That's a good question. So intercommunication is mainly it will be handled by your API activity, right? So, and you can certainly control how many services are accessing your service. I'm sure you have seen the slide on a Death Star. It's one of the popular slides that we have when we talk about microservice. But you can imagine that some of the building block service will have a lot of dependencies, and a lot of services will be accessing those. And the main way to control who can access is by giving proper access and authorization, as well as throttling or rate limiting the other services. That's the way to control how many people are accessing what type of request response you want to provide. So there's another question by Piotr. How do you manage when one service needs something more from another service? Do you create a new one, or do you simultaneously evolve the existing one? So I guess the question is, when do I decide when my microservice is ready to split apart, or do I go from, when do I have one microservice to 2 or 3 microservices? And I think the design pattern there is, are you able to split your data? So if you take the analogy of using a DynamoDB table, and if you can have your access patterns and your tables, if you can split them apart and have separate set of APIs in order to start thinking about another microservice from a single microservice to tons of microservice, then that's the way of, I think that's the right methodology in order to think about splitting a microservice. There's a question about, are you going to cover anything about hybrid approach like on-prem and cloud, and what impacts and steps taken to reduce the complexity? I think the overall response there is, you can certainly use the best practices that I talked about, microservices design patterns and principles across your hybrid environment. But I think the main advantage of using cloud-based or Amazon-based managed services is when you leverage the managed service within your design pattern. So you don't have to handle the operational side of running a set of servers in order to handle your NoSQL workload. You can easily spin up or specify the amount of throughput in terms of DynamoDB and run your NoSQL solution using that. Also, if you have a SQL-based workload, you can leverage RDS. So your operational complexity will be minimized when you use cloud-based services. All right, so that's all I have for today. I think we're out of time. Thank you everyone for joining. I certainly recommend to take a look at AWS X-Ray and kick the tires. And also, in the meantime, take a minute or so in order to provide our polling or answer the questions on our poll. Thanks a lot, and have a nice weekend.
At this time, I'd like to extend a special thank you to our presenter, Peter, today for the great presentation and demo, as well as to Prahlad, Brandon, and Hui for our answering all the questions in our Q&A panel. If you have any comments on our previous or upcoming webinars, or any suggestions on topics you wish AWS to cover in the future webinars, please feel free to email us at aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. Thank you to the audience today for taking time to join us. Enjoy the rest of your day. At this time, you can disconnect.